This question about polar coordinates. At first we need to show that the point A has this polar coordinate. We are given the information that the point A is the tangent to the curve, this curve at A, the tangent to this, which is basically this line, is parallel to the initial line. So as this is parallel to the initial line, we know that dy by d theta would be 0. So we also know that y is equals to r sine theta, and we know r as 4a1 plus cos theta. So we can write r as r, we substitute the r over here and we get this expression. We can directly differentiate this. The first term is easy to differentiate, the second term we just use the product rule and we get this expression over here. We simplify a bit. We get 4a cos theta minus 4a sine squared theta plus 4a cos squared theta equals to 0. We see that we can convert this into a simple quadratic equation if we change the sine squared to a cos square. So we can write this sine square as 1 minus cos squared theta, and we do that and we get this quadratic equation. We can directly calculate the values for this. This is cos theta equals to half and cos theta equals to minus 1. We get these two values. The range of theta is from 0 to pi, but pi is not included, so we reject this value pi. So theta is pi by 3, and the value of r is 4a1 plus cos theta. Here cos theta is half, so we write 4a1 plus half, which is 6a. So a has polar coordinate 6a comma pi by 3, and we have shown that successfully. We need to find out the shaded area, the area of region R. The region R is a segment, so we can find out the area by subtracting the area of the triangle OAB from the sector OAB. Initially we are given the information that the angle AOB is pi over 6. Initially we know that the angle from the initial line to OA is pi by 3 and its distance is 6a. We draw a line from O to B, and then we show the angle that we are given. So we also know that from here that the angle OBO to the initial line is pi by 6. For B, written as a polar coordinate r comma theta, the value of theta is pi by 6. Using the value of pi by 6, we can find out r for B using the formula that we are given over here. So we plug in the equation 4a 1 plus cos pi by 6, and we get the distance 4 plus 2 root 3a. We have done the calculation over here. 4a 1 plus 3 root 2. We get this as the value of r. Now we need to find out the area of the triangle, which would be half times 6a times 4 plus 2 root 3a times the sine of pi by 6. This is what we have done over here. Let's go there. This is what we have done over here. The value of sine over pi by 6 is half, so we can write this, and we can multiply the bracket over here 4 plus 2 root 3 with this half and half, which would be 1/4. So we get 6a square 1 plus root 3 over 2. This is the area of the triangle. For the area of the sector, we need to integrate the polar curve that we are given from the coordinate B to the coordinate A. For B, the value of theta is pi by 6. For A, the value of theta is pi by 3. So the limit is pi by 6 to pi by 3. This is the area of the sector. So r square would be 6. This square is 16a square, and then the square of this, which we have written over here. And this is the formula of the area of we obtained from a polar coordinate system. So basically, for a polar curve, the area of the part, this area from B to A, has a formula of half r square d theta with the limit from the angle subtended at this point to the angle subtended at this point. So we get this equation. As 16a square is constant, we can take it out of the integral, and we can expand the bracket. We need to expand the bracket of 1 plus cos theta square. So let's do that. And this is the expression we get. We cannot integrate cos square theta directly because we don't know the formula. So we can write this as half 1 plus cos 2 theta, the double angle formula. So let's do that. We can integrate cos 2 theta easily. So now we integrate and then we put the limits on. So the root 3 over 8 cancel out, and pi by 2 minus pi by 4 is pi by 4, and this is the area of the sector we get. We are still not done yet, as we need to find out the area of R, which is the area of the sector subtracted, and we take the area of the sector and subtract the area of the triangle from it. My bad. So this is the area of segment R. This is the sector area that we have found out just now, and this is the triangle area. We take a square common, and this is the equation we get. 8 root 3 minus 3 root 3 is 5 root 3, and minus 8 minus 6 is minus 14. So this is the area of the segment that we get, and this is in the form that they wanted in the question, which is a squared times n pi plus p root 3 plus q. Here n is 2, p is 5, and q is minus 14. And that's us done with this question.